Okay, so we're going to draw a radius, sure. Okay, so let's just draw the radius directly to the right of the center. Okay, so now let's read this next instruction together. Draw an arc length that is 1 radius long. Okay, so what that means is I want you to imagine, taking this radius and curving it, like I can't do it, but like, bending this down so that it fits on the edge of the circle. Okay, so yeah, it's a little hard to show you, but let me just do it on the board then. Okay, so like the size of 1 radius, I want you to imagine like curving it around the edge of the circle. So like imagine how, like if you had a piece of string that was this long, how far would it go if you curved it on the edge of the circle? Okay, so again, it's not going to be perfect, but again, if you just imagine you go here, then you go here, and then you bend it down a little bit, right? So it might go like around here to here, right? So it would go around here, I would say. Okay, and so where that ends, connect it back up to the center. Okay, so the arc length that was formed, this is equal to the radius, right? So here is a radius, and this length is also a radius. And this is also a radius, right? So everything's a radius. Okay, so it's kind of like a triangle, but it's not because this is curved, it's not straight. Right, but again, hopefully you can see that this distance, and if you curve it around, this distance are all equal. Okay, so the angle that's formed at the center of the circle, the central angle, this angle is measured as 1 radian. Okay, so this is an alternate way of measuring how wide an angle is. Up till now, we've been using degrees, right? Which is why I've been making such a big deal about the little degree symbol. But we can also measure angles in radians. Okay, and for a lot of calculations, radians are actually better, which is why, because it's based on the radius, right? So the fact that the arc length is a radius will be very useful in some situations. Okay, so this is a single radian. What if we went another radius around? Okay, so again, what if I measured that same distance, but then I did it over here? Okay, so that would take me approximately right here, I would say, right? About the same distance. Okay, and again, I'll connect that to the middle. Okay, and again, that would be 1 radian, and this would be a different radian. So combined, this would now be 2 radian. Okay, and let's do a third one. Okay, so if we add on a third length of a radius, that would take us approximately right here. Okay, so it's not quite halfway. If you notice, it's not a straight line at the bottom. It's a little bit less than half of a circle. Okay. So I want you to do the same thing for these circles below. For each one, follow the 3 steps that I did for the first one. Okay, so go and take a couple of minutes and try that out. Okay, so here the radius is bigger, right? So we still, again, kind of measure, okay, how far is this? And then you bend it around the edge of the circle. Sorry. Okay, and then the second one. And then the third. Okay, so again, the radius is longer, which means this arc length is longer also. Okay, then this next one's a little bit smaller. Okay, and then even smaller. Okay, so the radius is smaller, but then the circumference is also smaller, right? So it doesn't have as far to go. Okay, so even though all four of these circles were different sizes, hopefully you see that the third radian of each one always ends in the exact same spot, right? It's always a little bit less than half the circle. Okay, so we can say that first. Okay, no matter what size the circle is, I'll use numbers. Okay, so hopefully that makes sense, right? If you think about a square, it doesn't matter how big or small a square is, it always has 360 degrees. Okay, so similarly for the circle, no matter how big or small the circle is, it always has 360 degrees, but now we're trying to find how many radians it has. Okay, so again, hopefully you agree that 3 radians is not quite half. So half a circle needs to be a little bit more than 3 radians. Any predictions on exactly how many radians would make up half a circle? Anyone know any interesting numbers that are slightly more than 3? Pi, sure. Pi is about 3.14, right? So to hopefully better understand this, go ahead and look up at the board so you can watch this animation. Okay, so here's what we did, right? We had a circle, and no matter what the radius is, r, right? Then what we did is I told you to bend that radius around the edge of the circle. Okay, so that angle that's formed, this angle is called 1 radian, or RAD for abbreviation. Okay, then I had you add on a second one and a third one, slightly less than half a circle. So if you add on a little more, half a circle is pi radians. So if you double that, then a full circle would be 2 pi radians. Okay, so we'll watch it one more time just to make sure we understand. So again, the word radian is very similar to radius, right? Not a coincidence. It's formed by bending a radius around the circumference and connecting it to the center. Okay, so again, 1 radian, 2 radians, 3 radians. So a little bit more, about 3.14 radians, or pi radians is half a circle. So if you want the full circle, you just double it. Okay, so a full circle is 360 degrees, but we can also describe a full circle as 2 pi radians. Okay, so let's write that down. Okay, half a circle has pi radians. And that means a full circle has 2 pi radians. Okay, so just like any length can be measured in either feet or meters, right? It's just two different systems. Anything that was measured in degrees can now be measured in radians. Okay, so angles we know are typically measured in degrees. Now we can measure in radians, but also arc measures. Arc measures can be in both degrees and radians. Okay, so this is really just something you're going to have to memorize, the fact that a full circle has 2 pi radians. All right, so do we have questions on any part of this first page? Okay, so let's turn to the second page then. Okay, so we want to know how to convert between these two methods. There's many different ways to do it, but I think the one that people best remember is you set up a proportion. Okay, so degrees out of 360 degrees equals radians out of 2 pi. And radians, notice, are what we call unitless or dimensionless. There's definitely no degree symbol, and you don't even need to write the word radians or RAD after it. If an angle does not have a degree symbol, you can assume it's radians. So that's why I've been making such a big deal about you guys putting your degree signs, because if you leave off the degree sign, you technically mean 360 radians instead of 360 degrees, which is very different. Okay, so let's see how we can apply this. Convert 120 degrees to radians. So since this one is degrees, you're going to plug that in up here. Okay, so we have 120 out of 360 degrees. We don't know how many radians that is, so we'll call it x, but it's out of 2 pi. Okay, so this is a proportion. We have two fractions equal to each other. I always recommend reducing if possible. So before we even look at the other side, we can reduce this. 120 over 360 reduces to 12 over 36, which reduces to 1/3. Okay, and now that you've reduced, now we can go ahead and cross multiply. Remember, with proportions, we can cross multiply. So on this diagonal, we have 3 times x. On the other diagonal, we have 1 times 2 pi. Okay, so 3 times x is 3x. 1 times 2 pi is just 2 pi. And then to get the x by itself, we divide both sides by 3. Okay, so what we showed is that 120 degrees equals 2 pi over 3 radians. Okay, and let's do one the other way. Convert 5 pi over 4 to degrees. So this time, the given angle does not have a degree sign, which means it's radians instead. Okay, so that's going to be radians. So we don't know how many degrees, so x out of 360 degrees equals, so the 5 pi over 4 is all in the numerator. And then over 2 pi as the big denominator. Okay, so again, I would recommend simplifying the fraction within a fraction first. Okay, so let's just focus over here. 5 pi over 4 divided by 2 pi. You can write that sideways at first. 2 pi is 2 pi over 1. Then instead of dividing fractions, we typically multiply by the reciprocal of the second number. Okay, so before we multiply, we can reduce the pi's because they are common factors of the numerator and denominator. Okay, so you get 5 times 1 is 5, over 4 times 2 is 8. Okay, so this fraction reduces to 5/8. And don't forget, we still have the left side. Okay, so now that we're here, again, we can cross multiply to solve this proportion. We have 8 times x equals 5 times 360 degrees. Okay, and then now we want to get the x by itself, so we divide both sides by 8. Okay, so we showed that 5 pi over 4 radians is equal to 225 degrees. Okay, and I'll do one more with you. Convert 4 radians to degrees. Okay, so it tells you it's radians, so it's going to go over here in the radian spot. Okay, so we don't know how many degrees. So x out of 360 degrees equals 4 out of 2 pi. Okay, notice it's not 4 pi radians, it's just 4 radians. Okay, so this time the fraction's a little bit easier to reduce. All right, it just becomes 2 over pi. Okay, let's go ahead and cross multiply. We have pi times x equals 2 times 360 degrees. Okay, so pi times x. Pi is a number, just like 2 or 5. So you can divide both sides by pi. Okay, so 720 degrees over pi. Okay, so here the instructions say round to the nearest hundredth. Okay, so I'm just going to use the pi button on my calculator. I'm going to type in 720 divided by pi. Okay, 720 divided by pi. Okay, and then we're going to round to the nearest hundredth. So the next number is not 5 or more, so it stays at 8. So 229.18 degrees. Okay. So I'm gonna have you take a couple minutes to try out the rest of this page. Okay, so as always, let me know if you have any questions. Okay, so this next one, x over 360 degrees equals 11 pi over 6 all over 2 pi. Okay, so I would definitely try to simplify this side first. again, it helps to write it sideways. And then you can multiply by the reciprocal. So the pi's cancel out, leaving 11 over 12 as the fraction. But don't forget, that's not the final answer. You still gotta set it equal to this side. Okay, so then you have 12x equals 360 times 11, which is a big number. And then divide both sides by 12. Okay. These next two, well, let me just write the answer here. Okay, I will do problem 7 though, because it's always a little tricky when the pi is not there for the radians. Okay, so we don't know how many degrees we have. But you have 6.1 radians out of 2 pi. Okay, so on this diagonal, you have 2 pi times x. On the other diagonal, you have 360 times 6.1. Okay, so using my calculator, 360 times 6.1 is 2096. 2196. And this would equal 2 pi x over here. Okay, so let's say I want to divide both sides by 2 pi. If you want to do this all in one step, you have to be careful about the way you type it into your calculator. Okay, so let me show you. If I type in 2196 divided by 2 pi, this answer doesn't make any sense, right? How could it be like 3,000 degrees? The problem is your calculator does 2996 divided by 2, and then it multiplies by pi. The pi is supposed to be in the denominator. So the way you have to type it is parentheses 2 pi. Okay, so the correct answer is 349.50. And these are degrees. All right. So any questions about how we convert between degrees and radians? Yeah. For degrees, do we have to do the crossing or do we just multiply it? Okay, good question. You could do it that way instead. So going back over here, from that same starting point, Jacob asked, could you start by canceling out this denominator? Sure. You could instead multiply both sides by 360 degrees. This cancels out. Here, you might reduce these. Okay, but be careful, the pi is still there. So yeah, you get the same answer. So yes, you can solve it that way instead. Okay, other questions? Okay, so again, every single problem where we've ever used degrees, we can now solve in radians instead. Okay, so looking at this third page, last class, we learned how to calculate arc length, which remember is like part of the outside of the circle. Okay, so the formula we learned was arc length equals the fraction of the circle, degrees out of 360, times the full circumference. Okay, and then the full circumference you can either say is 2 pi r or pi times diameter. Okay, so if we are in radians instead, the vast majority is the same. Okay, we can still find the arc length. But in order to find the fraction of the circle, because we're not in degrees, because we're in radians, right? What is 360 degrees? It's a full circle. Okay, so you still want to divide by a full circle, but instead of calling it 360 degrees, you call it 2 pi radians, right? So either way, you're dividing by a full circle. It's just a matter of notation. Okay, and this part stays the same. Okay, so let's do an example together of finding the arc length when the angle is in radians. Okay, so I asked us to find the arc length of MN. Remember, 2 letters means it's a minor arc. So MN is this one. Not this one, not the long way around. Okay, so this one's going to be a little bit of work then, because we don't know the central angle and we don't know the arc measure, right? But we were told that this angle out here is 3 pi over 2. Well, again, a full circle is either 360 degrees or 2 pi radians. Okay, so first we could say that 3 pi over 2, and we'll call this x, plus x equals 2 pi. Again, why 2 pi? Because it's a full, these two angles together make a full circle. Okay, so just like if in a different problem I gave you this, I told you that this is 290 degrees, right? Over here, you would say, okay, 290 plus x equals a full 360. Right, that's what you would do for this problem. So it's the same idea here, except instead of adding to 360, they add to 2 pi. Okay, so let's get the angle. Okay, what is 2 pi minus 3 pi over 2? Let's get a common denominator. It's 2 pi over 1. And then common denominator. Okay, so the remaining angle must be pi over 2. Okay, so now that I have that, a central angle is equal in measure to its intercepted arc. All right, so this arc is also pi over 2 in arc measure. Okay, but this is not the same thing as the arc length. Okay, so what we need to do is use our arc length formula. Okay, so arc length equals radians over 2 pi. Okay, this arc measures pi over 2, but that's just the numerator. You still have the divided by 2 pi. Okay, and then times the full circumference. Since we're given the radius, let's use the 2 pi r version. Okay, so before we continue, make sure you understand where this comes from. All right, this is the measure of the arc, this is a full circle, and this is the full circumference. Okay, so there's different ways you can simplify this, but the way I'll do it is first I'll just combine these up. 2 pi times 4 inches would be 8 pi inches. And then over here, I need to simplify pi over 2 all over 2 pi. Okay, so again, fraction bar means divided by. So pi over 2 divided by 2 pi becomes pi over 2 times 1 over 2 pi. The pi's cancel out, leaving you with the fraction 1/4. Okay, so 1/4 times 8 pi. Arc length then equals 2 pi inches. Okay, so we only had to subtract from 2 pi because I told you this measurement when we needed this measurement instead. Okay, you won't always do that. Okay, so any questions on this first problem? Okay, so same idea for this sector area. Okay, so what we learned last class is that to find the sector area, you take the degrees out of a full 360 degrees times the full area, which is pi r squared. Okay, so you should be able to predict the radian version. You're still finding the sector area. You still will multiply by the full area. But the difference, you're not going to be given degrees, you're going to be given radians. Okay, so instead of dividing by 360 degrees, you'll divide by 2 pi. Okay, so let's apply it over here. So this time I do give you the angle that's shaded, right? I did not give you this angle. I gave you the actual angle. So we're just going to use the 2 pi over 3 directly. We don't need to subtract from 2 pi like we did earlier. Okay, so sector area, right? The area of this slice of the circle. The radians is 2 pi over 3. And that's all over 2 pi. And then times the full area, which is pi times the radius squared. Okay, so again, I like to simplify this part first. 12 squared is 144. Keep the pi, keep the, well, the centimeters is now squared. Okay, off to the side, let's simplify this fraction within a fraction. 2 pi over 3 divided by 2 pi converts to 2 pi over 3 times 1 over 2 pi. So here, the entire 2 pi can cancel out, leaving 1/3. Okay, so you have 1/3 times 144 pi centimeters squared, which becomes 48 pi centimeters squared. Okay, so basically what we did is we said the full circle has area 144 pi. The shaded section is 1/3 of a full circle. So 1/3 of the full circle gives us the sector area. Okay. All right. So why don't you go ahead and try the 2 problems below, please? Okay, so when I asked you to find the sector area, notice that the angle, the central angle, it's just 3 radians. It is not 3 pi radians. It's just 3 radians. Okay, so 3/2 pi times pi r squared. Again, not 3 pi, just 3. So this time we can't really simplify the fraction at all. So just leave it alone. We can simplify this part. 5 squared is 25. So just keep the fraction. Okay, so now we multiply. Again, this is not cross multiplying. It's a regular multiplying, so multiply straight across. You are able to reduce these pi's. Okay, so up top you have 3 times 25 is 75. On the denominator, 2 times 1 is 2. Okay, so 75 over 2 inches squared, or if you want, 37.5 inches squared. Okay, so notice there's no pi in the answer. So yeah, that's one example of when radians work out nicely, right? If we were doing degrees, you would have a long decimal that goes on forever. But in this case, the numbers work out very nicely. Okay, and then over here, find the arc length if a central angle measures pi over 5 radians, radius 20 miles. That's very large. So it always helps to draw a picture. Okay, so the radius is 20 miles. And then pi over 5 radians, you might not know exactly how big that is, but I'll just draw it like this. Okay, so this time we're finding arc length. Okay, so we have pi over 5 radians, but we know a full circle is 2 pi. Okay, and then what do we multiply by? Because we're finding arc length, we need to find the full circumference, right? Not the area, but the circumference for arc length. Okay, so 2 pi times 20 would be 40 pi. Over here, okay, these pi's are able to cancel out. Okay, so 1/10 times 40 pi divided by 10, 4 pi miles. Okay, so again, it's really the same thing we did last class. The only difference is instead of dividing the degrees by 360 degrees, you divide the radians by 2 pi radians. Okay. All right, so on the back is some mixed practice. Okay, so go ahead and try these, please.